All right, learning targets 1 and 3 deal with writing equations and graphing linear relationships from descriptions. So basically word problems here is what we're going to look at in this video. We're going to start off with Miss Olson paying Mr. Boyd. And I'm sorry if Mr. Boyd ever sees this. This is just a word problem. Miss Olson is paying Mr. Boyd $3 at the beginning of school for showing up to work. She then pays him $4 every hour he is at school until the end of the day. So we need to figure out, basically in these word problems, what numbers give us our slope and what numbers give us our y-intercept. So we have 3 and 4 right now. I want to take a closer look at these two numbers and decide which one is our slope, our constant rate of change, and which one is our y-intercept, our starting value. So this $3 is at the beginning of the day. She gives it to Mr. Boyd just for showing up to work. That kind of sounds like it only happens once, and it's at the beginning of the day. So that sounds like a startup value or a start value, which I know is another word for our y-intercept. So that's going to be my y-intercept is 3. My slope is something that happens every hour or every minute or every so often. So I notice here that it says she pays him $4 every hour he's at school. So that makes sense that it would be my slope, $4 every hour. So if we look at hours here, let's add a 0 column to our hours. So when he gets to school at 0 hours, he gets $3, right? And then for every hour he's there, he gets $4 more. So 1 hour is going to be 7. 3 plus 4 is 7. 7 plus 4 is going to give us 11. 11 plus 4 will give us 15. 15 plus 4 will give us 19. 19 plus 4 will give us 23. 23 plus 4 will give us 27. 27 plus 4 will give us 31. And 31 plus 4 will give us 35. Then I'm going to take a look and make a graph of this, okay? And I'm only going to graph the first maybe 4 points on here. So if I make my graph here, I'm going to do 0, 1, 2, 3, 4, and these are my hours, and time is an independent variable, so that goes on the x-axis. And then my y's, I'll count by 5s here, because at 4 I have to get up by 23. So 10, 15. And I'm just going to plot some of these points. This is money, okay, in dollars. And at 0, I know he gets $3. At 1 hour, he'll have $7. 2 hours, he'll have $11. Oops, I have that second dot a little high. 2 hours, he'll have $11. 3, he'll have 15. And 4, he'll have 23. At 4, he'll have 19. And we can do one more. 5 will be 23. So I can see I have a line there. And then I'd like to make an equation for this. Sometimes with these equations, with these word problems, you can start with your y-intercept. So she gives him $3 plus $4 for every x, or for every hour. And if you want to go back to the y equals mx plus b, that would just be 4x plus 3. But if you like this new way of writing equations where we start with the starting value and then use the slope to go up from that, you are more than welcome to do so. So let's do a couple as practice. You walk into an elevator in the basement of the building and its control panel says 0 for the floor number. As you go up, the numbers increase one by one in the display, and the elevator rises 13 feet on each floor. You're asked to make a table of the floor values from heights from floors 0 to 4, sketch a graph, and write an equation for the situation. So I'd like you to pause the video and do that now. All right, so if we go over these numbers here, we're going to start. I'm going to pick out, I have 0 and I have 13 here. And from the description here, I'm going to say that my y-intercept is 0 because I know I start in the basement. Okay, and then my slope is 13 because I'm growing 13 feet for each floor. So if I make a table over here, my floors and my height, my floors at 0, I'm at 0. At 1 floor, I go up 13 feet, so I'm at height 13. 2, 13 plus another 13 is going to be 26. 3, 26 plus another 13 is going to be 39. And then 4 would be 52. All right. If I graph these, 1, 2, 3, 4, and you should be on graph paper with a little neater thing there. And then I'm just going to count by 13. So 13, 26, 39, 52. And my dots should go right up like that. And then if I plug my slope and y-intercept into an equation here, my slope would be 13, my y-intercept would be 0, or I could write that as I start at 0 and I add 13 for each x or for each minute. Let's try another one. Manisha starts her exercise routine by jogging to the gym. Her trainer says this activity burns 215 calories. Her workout at the gym is to pedal a stationary bike. This activity will burn 3.8 calories per minute. So we're going to make a table for Manisha's calories after she starts pedaling. So we're going to include that 215 calories she's already burned. That'll be kind of our starting value. And then we want to look at 0 through 3 minutes. Okay, you're asked to sketch a graph of the calories over minutes and make an equation. So if I'm going to look here, pick out my numbers. 215, it's when she gets to the gym, that sounds like a starting value. 3.8 is calories per minute. That sounds like a slope. Okay, so if we look at minutes versus calories, at 0 minutes, she's already burned 215 calories after getting to the gym. At 1 minute, she'll have burned 218.8, because I know 215 plus 3.8 is 218.8. At 2 minutes, she'll have burned 222 calories, 0.6, and at 3, she'll have burned 226.4, I believe. Okay, so if we make a graph here, as we go minute by minute, and I'm going to spread those out. As we go minute by minute here, 1, 2, 3 minutes, we can't start down here at 215, can we? We're going to have to start, if we're going to, 215 is a ways up. If we make 215 right here, is she growing very much each minute? Not really. So our line is going to have a very shallow slope to it. We do not grow very much each minute. So if we make a line that fits our data here, this line is not going to increase very much, but it is increasing slightly. Okay, and then if I plug this into my equation, my slope was 3.8 and my starting point was 215, or if you like to say she's burned 215 calories and then she's burning 3.8 more with each second or each minute, you can do that as well. Let's try another one. Ben's school is 3/4 of a mile, or 3,960 feet away from his house. After school, Ben walks straight home at 330 feet per minute. We're asked to make a table with Ben's distance from home for 0 to 4 minutes. Okay, so be careful here as you do this. It's his distance from home. He starts 3,900 feet away from home. So go ahead and make a table, sketch, and write an equation. And then we'll talk about it. So pause the video. All right, so he starts 3,960 feet away, and then he goes 330 feet per minute. So I'm going to say this is a starting point, or a y-intercept, and this looks like a slope to me because it's feet per minute. So we're asked to make a table. So this is his distance away over, actually let's do minutes versus distance away. Alright, so we at minute 0 are going to be at 3,960 feet. And then we're going to take away 330 feet per minute because of Ben walking away from school towards his house. Okay, so 1 minute he gets 330 feet closer, so that would be 3,630 feet. 2 minutes he'd be at 3,300 feet. 3 minutes he'd be at 2,970 feet. And 4 minutes he'd be at 2,640 feet. Okay, so if we make a graph of that, we're going to start up here at 3,960, and we're going down 300 for each minute. Okay, so our line is going to be going down there, and I'm sure your graph looks a little better than my sketch there. So if I go ahead and plug in my slope, let's look at this one first. We start at 3,960 feet, and then we are adding or subtracting 330. So our slope would be a negative 330, and our y-intercept 3,960. All right, let's take a look at another one. A car is moving at a speed of 68 miles per hour towards Dallas. The car starts 272 miles away from Dallas. So pause the video. This is a lot like the one of Ben walking home, and make a table, graph, and equation for this information. All right, so let's look at this. Our hours and our distance. We start at 0 hours, we start at 272 miles away. After 1 hour, we're going to subtract 68 from that, so we'll be at 204 miles away. After 2 hours, we'll be at 136, and after 3 hours, we'll be at just 68, and 4 hours, 68 minus 68, we're going to be 0 distance away from Dallas. So at 4 hours, they'll have gotten to Dallas. And if I look at here, my two numbers, this looked like a starting value. This looked like a slope to me. Okay, so if we sketch a graph, again, we're starting away 270, and it looks like we're going down each point, and then after 4 hours, we're at 0. So at 4 hours, we're at 0 miles away from Dallas. So again, we started at 272. Oops, this was supposed to be a 2. And we subtracted 68 miles per hour. So our slope would be a negative 68, and our starting point was 272. All right. Last one here. A long-distance telephone carrier charges $1.38 for international calls of 1 minute or less, and 36 cents for each additional minute. We're asked to make a table, sketch a graph, and make an equation of their cost as the minutes increase. So pause the video and do that. To check here, I'm going to look at my two numbers. This one to me is 1 minute or less. So that means right away, no matter how, after you push start on your, or call on your phone, that's our starting value. And then for each minute over that first one, we go up, okay? So this would be our slope. All right, so we're going to start at minutes and cost. At 0 minutes to 1 minute, it's going to cost us $1.38. And then after 1 minute, it's going to cost us $1.74. $1.74. After 2 minutes, it'll cost us $2.10. 3 minutes and more, it'll cost us $2.46. And 4 minutes, it'll cost us $2.82. So on a graph here, we're starting up at 1.38, and we're going up just 36 cents per minute there. So that's our graph there. And if we plug in our start and our slope was a positive 0.36, and our y-intercept was a 1.38, or if you'd like to think of that as starting at 1.38 and adding 0.36, that's fine as well. So hopefully you have a better understanding of how to make graphs and equations from a description. If you need more practice on this, please let me know.